Welcome back, Algebra 1, for today's lesson where we're going to be reviewing all the different types of polynomials that we factored up to now. Just a quick little reminder, when we factor a polynomial, we're writing it as a product of things, right? Something times something. Another thing you should remember is that whenever you're factoring a polynomial, the first thing you should always do is factor out the GCF. Now, if the GCF is just 1, you're going to continue factoring using the methods that you've learned so far. So let's look at our very first example here. In this case, I noticed that when I look at these three terms, I have 2x squared minus 10x plus 12. They have something in common, right? My greatest common factor here would be 2. If I factor out the 2 carefully, I'm left with x squared minus 5x plus 6. Our goal now is to focus on factoring out this trinomial here. In the end, when I write down my final answer, I know I'm left with 2 times whatever x squared minus 5x plus 6 factors into. And so what we're going to do is we're going to factor out this trinomial using the Xbox method. I'm going to create a little box right here where the first box has the first term, the last box has the last term. And to figure out how to distribute the negative 5x, we're going to create the x. The product is 6. The sum is negative 5. We're going to ask ourselves what two numbers multiply to 6 and add up to negative 5. That would be negative 2 and negative 3. And then from there, I know I get to put negative 2x in one box, negative 3x in the other box. And then from here, what's nice is that I know that this first box is x squared, which means that it has to be x times x. And if you carefully fill out the rest, you'll get something like this. And a quick little check here, negative 3 times negative 2 is positive 6, and that's always nice. So when you write down your final answer, it will be 2 times the quantity of x minus 3, x minus 2. And this is your final answer. So hopefully you see how we factor out the GCF. That was our very first step. Let me show you what would happen if I did not factor out that 2 from the very beginning. So let me just copy down this problem here. Creating the X box. First term goes in the first box, last term goes in the last box. Now if you remember, what we're going to do here is we're going to multiply 2 times 12. That gives me 24, which is what my product's going to be. And my sum is going to be negative 10. That's the coefficient of my middle term. What two numbers multiplied to 24 add up to negative 10? Negative 4 and negative 6. That's where I put negative 4x in one box, negative 6x in the other box. And then from there, what we want to do is pick any row or column and find the greatest common factor. So I'm going to choose the first column here, 2x squared minus 4x. The GCF for those two terms would be 2x. Carefully fill out the rest. And so when you write down your final answer, you'll get 2x minus 6 and x minus 2. Now the problem is, if you don't factor out the GCF as your first step, you'll get this. And the problem is we're not done. And the reason why we're not done is because if you look at this binomial right here, 2x minus 6, do you notice that there is a greatest common factor between 2x and negative 6? You have to keep going, in other words. So if you just factor out 2x minus 6, the greatest common factor will be a 2. If I factor out a 2 from 2x minus 6, I'm left with x minus 3. This x minus 2 at the very end still stays there. And then you'd be done. So the problem is, if you stop right here, technically you're not done because you did not factor it all the way. You want to make sure you factor it completely, which means that there should be no greatest common factor among any of the factors. And so that is why it is so essential that anytime you're doing a factoring problem, this is the first thing you should always do. Factor out the GCF. So guys, I hope you understand the importance of factoring out the GCF as your first step. And then from there, you can use whatever methods you know to factor out the rest of the trinomial or the polynomial for terms. So at this point, I want you to look at number 2. I want you to try number 2 on your own. Pause the video and press play when you're ready. Hopefully the first thing you noticed was that if you look at all three terms here, the greatest common factor is 3. So I'm going to carefully factor out the 3. And then from there, I know that in the end, my final answer will be 3 times something. Our goal now is to focus on this 3x squared plus 5x minus 12. And we want to make sure we factor that trinomial. So what we're going to do is create an X box. first box, first term, last box, my constant, and then from there I'm going to create an x. To figure out the product, you want to make sure you multiply the 3 and the negative 12. That gives me negative 36. The bottom, the sum will be 5 because that's the coefficient of my middle term. We want to ask ourselves what two numbers multiply to negative 36 and add up to 5. That would be 9 and negative 4. So I know I'm going to put 9x here, negative 4x here. And then from here, you want to pick any row or column and find the greatest common factor. So what I'm going to do here is I'm going to choose the first column, 3x squared and 9x. The greatest common factor of those two terms will be 3x. And then from there, we can kind of fill out the rest of the table. There would be an x there, minus 4 here, plus 3 here. And then you can do a quick little check. 3 times negative 4 is negative 12, which is nice. When you write down your final answer, you'll have that 3 in the front still. You'll have x plus 3 and 3x minus 4. Hopefully you're able to get that correct. If you made any mistakes, make sure you really learn from it. But always remember, your very first step, you want to factor out the GCF. Always look for the GCF, okay guys? I can't emphasize that enough. All right guys, let's look at number 3. So in this case, when I factor this trinomial, the first thing I want to ask myself is, what is the greatest common factor? Because that's what you want to factor out. Now if you look at 25m squared minus 20m plus 4, my GCF is just 1 here. So what I'm going to do next then is go right into what technique I should do next. Now you can totally use the Xbox method here, but if you notice, this trinomial has a certain structure. If you notice this first term here, you can write this as 5m squared. The last term, you can write this as 2 squared. And do you notice that 20m is 2 times 5m times 2? What this tells me is that this is a perfect square trinomial. Here's a minus, here's a plus. And so when I factor this out, I know I'm going to get something of this form. I'm going to put a minus here simply because there was a minus in that middle term. My first term will be 5m because that was the first term. My second term will be 2 because that was my last term. This is my final answer. This is going to be a lot quicker than using the Xbox method, but you always have to look for that structure. Let's look at another example together, number 4. So for this one, the first thing you always want to do is look for the GCF. Here we have 32x squared minus 18. My greatest common factor here would just be 2. What I'm going to do is I'm going to pull out 2, and when I do, I'm left with 16x squared minus 9. And now from here, I notice that what we're going to be focusing on is this binomial. A couple things you should notice here is that there's 2 terms and there's a difference. Not only are there 2 terms, but each of these terms, if you notice, it can be written as something to the power of 2. 16x squared is 4x to the power of 2. 9 is 3 to the power of 2. What this tells me is that this is a difference of squares, and I know a difference of squares will have a difference and a sum. I know the first term will be a 4x. I know the second term will be a 3. And I know that this is what it'll factor into. So in the end, when I write down my final answer, don't forget the 2 in the front. I'm left with 4x minus 3 times the quantity of 4x plus 3. And this would be your final answer. So make sure you always factor the GCF in your first step. It's going to make life so much easier, and plus you'll get the answer much more quicker, I think, in general. So let's look at our last example here. Here we have a polynomial of 4 terms. And hopefully you remember from last lesson what we do when we have 4 terms, right? We use factor by grouping. For this one, the first thing you want to do though is look at all 4 terms and see if there's a GCF. Now because there's 4 terms here, there's a little more to check. But if you do check carefully, you'll notice that the greatest common factor is just 1. So I'm going to go right into our Punnett square. Put the first term in the first box. Put the last term in the last box. And then it doesn't matter where you put the n squared in the n term. And then from there, you want to pick any row or column and find the greatest common factor. I'm going to do the first column here. 3n cubed and 18n squared. do this one carefully, right? Just do the numbers first. What's the greatest common factor of 3 and 18? That would be 3. What's the greatest common factor of n cubed and n squared? You always choose the smallest power of n. And then from there, you can carefully fill out the rest. This would be n, which, by the way, if you notice, n is the greatest common factor of this first row. So if I chose the first row, I would have still got the same answer in the end regardless. You can carefully fill out the rest. This would be a -5. This would be a +6. And then one last little check here. 6 times -5 is -30, which works out nicely. And so now when I write down my final answer, I can write this as 3n squared minus 5, n plus 6. At this point, you look at your answer, you notice that there's nothing else we can do, and this is our final answer then. So hopefully by now you get an idea of what you want to do when you factor. The first thing you always want to do is factor at the greatest common factor, okay? Don't forget that. This is essential because it'll make the numbers a lot smaller typically, and you'll get the right answer too. Because my only concern is if you don't factor the GCF, you might go to this example here and stop right here, which would not be incorrect because you didn't factor it completely, right? And so that's the reason why I always want you to look for the GCF first whenever you're factoring a polynomial. So guys, make sure you understand these concepts. This is pretty much all the different techniques of factoring we've learned so far. Go back and review some of your notes if you don't remember how to do some of this. And please let me know if you have any questions. Guys, I hope you have a wonderful rest of your day.